Hi there. Are you ready for today's science topic? Let's dive right in. Today, we will explore a really cool question, quite literally. How do cold packs work? You have probably seen them in sports, in first aid, or even in emergencies. So, let's find out together how they work. Have you ever seen a sportsperson get hurt during a game? Sometimes, instead of rushing for ice from the fridge, they use a special cold pack that works instantly. But how can a pack become cold in just seconds? That's the mystery we'll solve today. So, what is a cold pack? A cold pack is like a small pouch. Inside, it has water and a chemical salt. These two are kept separate at first. But when the pack is pressed or squeezed or shaken, the water mixes with the chemical salt. And suddenly, the pack turns very cold. Isn't that amazing? So, why does the pack become cold? Here is what happens. Inside, the chemical salt and water are kept separate until the packet is squeezed. Once squeezed, the inner pouch of water breaks and the water mixes with the chemical, and this mixing causes a reaction. This reaction absorbs heat from the surroundings, making the pack feel cold. Now, some chemical reactions absorb heat from their surroundings. These are called endothermic reactions. Endo meaning in. Cold packs use exactly this kind of reaction. They take in heat from around them, so the pack feels chilly. Now, reactions can also do the opposite. So while endothermic reactions take in heat, like the cold packs, exothermic reactions give out heat, like burning wood, which makes you feel warm. So exo means out. So cold packs is equal to endothermic, that is taking in heat, and burning firewood is equal to exothermic, that is giving out heat. Easy to remember? But wait, why do we even put cold on injuries? How does it help? Well, here is how it helps. First, cold reduces swelling. When you get hurt, extra fluid rushes to the spot, making it swell. Cold makes tiny blood vessels tighten, so less fluid leaks out. Second, cold slows the blood flow. By narrowing the blood vessels, less blood rushes to the injury. This prevents too much swelling or a big bruise. And third, cold numbs the nerves. That means the nerves send fewer pain signals to the brain, so you feel less pain. That's why cold is so useful right after an injury. But don't we need blood for healing? Now, here's what is interesting. Cold helps first by slowing down swelling and bruising. But even when blood flow is reduced, some white blood cells can still reach the injury and start repairs. Later, when the cold is removed, blood flows normally again, bringing more white blood cells, oxygen, and nutrients. That's when full healing continues. So, cold is for quick relief, but blood flow is for long term healing. You might wonder, why not just use ice? Well, ice melts quickly and can get messy. Also, ice isn't always available, especially outdoors. But cold packs are portable, quick, and clean. You can carry them anywhere, even in a backpack. That's what makes them so handy. Now, cold packs are used in many situations. They are perfect for first aid after sports injuries. They give quick relief for sprains, bumps, swelling, and they are super useful in places where you don't have a fridge or ice, like when you are out hiking in the mountains. A smart little science tool for everyday life. Alright, time for a quick recap now. Cold packs have water and a special chemical salt inside. When the chemical salt and water mix, the reaction absorbs heat and makes the pack cold. Endothermic reaction means taking heat in. Exothermic reaction means giving heat out. Cold helps injuries by reducing swelling, slowing blood flow, and numbing the pain. Cold packs are often better than ice, and we use them in sports, first aid, and emergencies. Great work remembering all of that. Now it's quiz time. Let's see how much you remember. What is inside a cold pack? Only ice, water and a chemical salt, white powder. Think back to the slide where we opened up the pack. Yes, the correct answer is water and a chemical salt. Why does a cold pack turn cold? Because it absorbs heat in a reaction, because it has ice, because it is put in the freezer. Remember what happens between the water and salt? Yes, the correct answer is because it absorbs heat in a reaction. Next, what type of reaction happens in a cold pack? Magnetic, exothermic, endothermic. Think back to the slide where we talked about the cold pack as well as the burning wood. Yes, for the cold pack, the correct answer is endothermic. Next question. How does a cold pack help in injuries? By making the area hotter, by reducing swelling and pain, by giving energy. Think about the nerves and blood vessels that we talked about. Yes, the correct answer is by reducing swelling and pain. Last question. Why are cold packs sometimes better than ice? They need to be kept in fridge. They smell fresh. They don't melt and can be carried anywhere. Remember the hiker on the mountain? Yes, the correct answer is they don't melt and can be carried anywhere. Well done, science champs. You have learned how cold packs turn chilly, why they help with swelling and pain, and how chemistry connects to real life. Keep observing, keep questioning, and keep discovering.